Throughout history, men have looked to the stars wondering what is truly out there. This is a short movie on what they have found. The Mesopotamians were the first people to make records of their astrological findings. They also built observatories just to look at what was going on in space. Patterns were able to be seen on how the moon moved. They were able to predict some lunar eclipses and how it repeats every 223 months. The Egyptians used astronomy for many practical everyday uses, such as calendars and determining where to put monuments such as pyramids and temples. Stonehenge was said to be in alignment to predict when the midsummer solstice and the midwinter solstice will happen. Some say that Stonehenge was created by aliens because humans would not have been able to create such figures. The Chinese made records of their observations. They recorded as many as 900 solar eclipses and 600 lunar eclipses. They did this over 2,600 years. The Chinese also recorded other astronomical events, such as meteor showers and comets. 585, Thales was able to predict when a solar eclipse was going to happen. Many people at the time could not do that, so it was quite impressive that he did. He also founded the constellation Ursa Minor and used the Little Dipper as a navigational tool. Pythagoras was one of the first astronomers to determine that the Earth is not round, but actually a sphere, as well as other objects in space such as other planets, the Sun, and asteroids. Pythagoras also made it apparent that the Earth and Moon rotate around the Sun, not the other way around. The Babylonians measured how long planets and formations took to get back to the same location. Therefore, they could predict when planets, such as Mars, will be in a month. They believed things in space had an effect on what happened on Earth. They also used mathematical expressions to determine where things would be. They could tell what time the sun would rise and set. Aristotle was a student of Plato. He determined that the circular motion was how planets move because that's the only thing that can repeat itself. He also supported that the Earth is round because when you drop something, it falls straight down from everywhere on Earth. Also, the Earth's shadow on the moon is always round. Also, if the Earth was flat, you would be able to see the same stars in Egypt as you do in Germany, but that's not true. Also, the moon shows different phases, therefore it also is a sphere. Aristotle also believed that the Earth is the center of the universe because of the way fire, air, dirt, and rocks and water move. Aristarchus applied geometry to the study of astronomy. He showed that it is possible to use geometry to find the distance to the moon and relative distances sizes of the sun and moon, though he never carried them out. Also, he stated that the sun has a diameter about 7 times as large as Earth. He also proposed that Earth spins on its axis once a day. Aristophanes used geometry to calculate the size of the Earth. The main limitation on his ability to find the circumference of the Earth was his dependence on other people's measurements of the distance between two cities. None of Hippocrates' major works survived, so most of what is known is based on reports of other astronomers who lived centuries later. Contributions were a refinement of Aristophanes' method of finding the distance to the sun and moon, improved determination of the year, and extensive observations and theories of motions of the sun and moon. In 134 BC, he discovered a new star, which led him to believe that the task of making what was probably the earliest systematic catalog of the brightest stars. The Mayans built many monuments and buildings and aligned them with the position of the sunrise and sunset at the equinox and solstice. Venus was identified with important God-significant cultural events such as battles and were timed to coincide with particular positions of Venus. The Mayan calendar kept track of Venus, the sun, and moon. Only a few books survived. The rest were deliberately destroyed by the Spanish following their conquest of Mexico and Central America. Ptolemy had many major accomplishments, such as the creation of a system that could accurately account for the motions of planets using a combination of regular circular motions. His method of describing the brightness of stars, called the magnitude system, is still used today. His most influential contribution to astronomy was his geometric model of a solar system. The Arabs and Muslims improved many observing techniques. They also improved the ways in which planetary positions were calculated. Their main contribution was preservation of the astronomy of the ancient Greeks and translation of their works. They were the first to build observatories that were organized and equipped with their modern counterparts. Copernicus proposed the first fully developed heliometric model of solar system. He wrote an outline of a sun-centered theory of solar system. Brahe made surprisingly accurate positional measurements of the brighter stars in the sky without using a telescope. He did this by repeating his works. This info was passed down to Johannes Kepler, who used it to develop Kepler's laws of planetary motion. Galileo was able to improve the telescope. He discovered the 4 largest moons of Jupiter, discovered that Venus has phases, and that the moon is not actually smooth but has many crevices. Kepler is best known for his laws of planetary motion. These works also provided one of the foundations for Isaac Newton's theory of universal gravitation. He also invented the type of refracting telescope that we still use today. Isaac Newton discovered the law of gravity. He also created the 3 laws of motion and was able to accurately describe the rainbow. Edmund Halley discovered a comet that is only visible every 75 years. He named it Comet Halley. Einstein proposed the theory of relativity in 1905. It describes the change in measurements of physical phenomena when viewed by observers who are in motion relative to the phenomenon. In 1915, he extended this theory, which includes the effects of gravitation. Mass and energy determine the geometry of spacetime, and curvatures of spacetime manifest themselves in gravitational forces according to this theory. Niels Bohr discovered quantum mechanics, which is the science of the very small. It describes how all matter works. Wolfgang Pauli came up with the exclusion principle. It stated that 2 things cannot occupy the same space. Heisenberg came up with the uncertainty principle, that you can't know the location and speed of an object. Edwin Hubble discovered that the universe is constantly expanding, and also that there are other galaxies. Lemaitre supported Hubble's universe expansion theory, and also came up with the Big Bang theory. Dr. Robert Oppenheimer was the father of the atomic bomb. After he knew what he could do, he wanted it to be destroyed. Hoyle came up with the principle that everything always had and always will exist. Penzias and Wilson discovered cosmic background radiation, which is electromagnetic radiation from the sky. Neil Armstrong and Buzz Aldrin were the first 2 people to land on the moon. They brought back samples that allowed us to study more about the moon.